In this video, we will show you how to simulate Golden Gate cloning on Mendelgen. Golden Gate cloning is a restriction cloning technique that takes advantage of type 2S restriction enzymes. Type 2S restriction enzymes cleave outside their recognition sites, leaving fragments with flanking overhangs. When designing the backbone and insert, we want to make sure that these overhangs that are created have homologous overhangs in other vectors. In doing so, these overhangs then direct the orientation and assembly of the final resulting vector. Now, we have a figure below that goes through these steps, and I want to go ahead and show you just to kind of make it more clear. So, in the first step, we're designing our inserts. Now, the type 2S restriction sites are shown as these little lines, and then the sequences are the actual what the overhang is going to be. So in the first step, we construct these insert fragments, and then the second step, it shows them. Now, definitely look right here. See, we have a CATG on insert 3 and a CATG on insert 2. So these overhangs are then going to match up. So when constructing the final vector, they'll be next to each other. And then also we want to look in the backbone here. We have ACTG as one overhang, and that will then match up in front of the gene of interest number 1. And then we have GGAG as also an overhang, and that will match up with gene of interest 3 on the end. So then when we go through the Golden Gate cloning, after the restriction and then the ligation that puts everything together, we see that we come with a final vector that has everything in the order we would like. Now, let's go ahead and show how we can do this on Mendelgen. Now, in this simulation, we're actually only going to use one insert just to kind of simplify everything. Now, in the first step, we need to choose the backbone from our library below. I've already constructed a backbone that will work well for this example, so I'm going to choose that one. I've labeled it right here as Golden Gate backbone, and then what the overhangs are going to be, and then the type 2S restriction enzyme that's going to be used. So I'll click on that. Now after I clicked, it will open the Mendelgen editor with the backbone shown in a circular map on the left and a sequence map on the right. Now before we actually do the simulation, I want to show you what I would like to accomplish. So on the backbone, we have this promoter region right here, followed by two type 2S restriction enzyme cut sites. Now, Mendelgen by default shows classic restriction sites and only single cutters. So in order to show the type 2S restriction enzyme that I would like, I need to go up to the cut site icon right here, click on the down arrow so I can open that up, and then I'll click X to get rid of single cutters, and I'll enter the enzyme that I would like. Now, see, this is then shown the recognition sites and the actual cut sites of the enzymes. Okay, now with the cut sites, remember we need to take note what the overhangs actually are. So in the backbone we have on the left TTAT, and on the right we have GACA. So then we're going to need an insert vector that has cut sites with homologous sequences. And so I've already actually constructed an insert vector that has this, and I'm going to show it to you. So in this insert vector, we actually have a luciferase reporter that will be added after the promoter. Now, when the restriction enzymes actually cut this insert vector, we're going to be left with the luciferase reporter in the middle and a TTAT overhang on the left. And then let's check out the one on the right. So the one on the right we see here is going to be the CTGT overhang. Now, going back to the backbone, let's ensure that works. Alright, so on the backbone, we see that we need this TTAT overhang on the left, so that's right, and we need this CTGT on the right. So, we therefore know that our insert is going to work with our backbone, and so we can proceed to actually doing the simulation. Now, to begin this simulation, I'm going to click on the cloning icon above. This opens a drop-down listing all the cloning techniques supported in Mendelgen. I'm going to click on Golden Gate cloning. Now this opens a new cloning tab with a panel down here that shows all the steps that need to be completed when running a Golden Gate cloning simulation. Now the first step has already been completed because it's just specifying the backbone, which is just the vector that's shown in the editor. In the second step, we need to choose our insert vector. This can be done in two different ways. either selecting a vector that's already been uploaded in our library or manually entering a new vector. In this example, I'm going to choose a vector that's already been uploaded, but I'm going to show you how to manually enter one as well. So to do that, first click on From Clipboard, and then under here you need to enter the new sequence's name. I'll go ahead and enter test, and then enter the actual DNA sequence you'd like to use. Since this one isn't going to be used, I'm just going to enter ACTG, and then click Add Sequence. This will then go ahead and put the sequence underneath of Insert Sequences. Now, I don't want to use this sequence, so I'll click the X to remove it. And I want to use a vector that I've already uploaded, so I'm going to switch over to From My Library. Then over here, we see there's a drop-down that I'll click, listing all the vectors that we have previously uploaded. Now, I want to select the insert vector that I showed you earlier that I've previously constructed, and I labeled them in the same way that I labeled the backbone. So I just have the luciferase, and then I have the two overhangs and the enzyme used. So I know I want the TTAT and I want GACA. So I'll click on this insert vector. That insert vector is then moved below insert sequences, so we can see it there. It's also highlighted in blue, so if we wanted to click on it, it would open a new window with that vector in the editor. Now, as we showed before, we could use more than one vector in Golden Gate cloning. So I could click on the drop-down again and select another one. However, in this example, I'm only using one. So now moving on to the last step, we just select the enzymes. Now, mine has already been pre-populated because earlier when I wanted to show you the restriction enzymes, I had to specify which ones I'm using. But I'll go ahead and remove them real quick to just show you how this works. So under select enzymes, it's actually a drop-down. So you click on that, and it will open a list showing all the type 2S restriction enzymes that have cut sites in this vector. And then on the left, this is the number of cuts on the backbone, and on the right, it's the number of cuts in the insert. If we had more than one insert, it would just list them further along. So this is our only enzyme that has cut sites on both the insert and the backbone, so I'll click on this. So now everything is complete and ready to go, and I'll just click on clone to do the simulation. Alright, cool. So our simulation has taken place, and let's make sure everything worked correctly. So remember, on the backbone we had originally this promoter site, and then we wanted the luciferase to be added after, and we see that it has right here. Okay, great. So that concludes our simulation for Golden Gate cloning on Mendelgen. Please check out our other videos to see other cloning techniques.